right, this is journal page 24. So yesterday we talked about proportional versus non-proportional graphs. Today we're going to look at non-proportional and proportional equations and proportional and non-proportional tables. So we're going to start with that we have two different kinds. So we have proportional equations. And over here I'm going to write non-proportional. Non-proportional. Sorry, I cannot speak. Oh, didn't leave much room to write equations. Okay? Alright, so for the form of proportional equations, we're going to be in the form of y equals kx. And we're going to put a note that there is no plus or minus, so we have no plus or minus in it. We're going to have no exponents. No exponents. It's going to be straight up y equals a coefficient and x. And I want to point to that k and put that it is a coefficient. So a number is going to fit there. Versus non-proportional, which are in the form of y equals mx plus b, where m is my coefficient. And we're going to put a note that b is not 0, because if it was 0, it wouldn't matter. It would be just in the same form of kx. And again, we still have no exponents. So we're going to look at some examples. So y equals 4x, y equals 1/2 x, y equals 0.6x, y equals 3 1/3 x. You hear that consistent? Y equals a coefficient and then x. Some examples of some non-proportional equations. So we have y equals 3x plus 4. Y equals 1/2 x minus 1. Now you may say, wait a second, that says plus b. Remember, I can always add a line, change sign to make that plus a -1. But it's that same concept. Y equals 9x plus 40. Y equals, it could even just be x plus 7. Because then it would have a coefficient, imaginary 1. Alright, so equations are pretty cut and dry. It's just y equals kx, y equals mx plus b. Alright, now we're going to look at proportional tables versus non-proportional tables. So proportional tables and non-proportional tables. All right, proportional tables versus non-proportional tables. Sorry, constantly coughing. All right, so for proportional tables, when x equals 0, y equals 0. For non-proportional tables, when x equals 0, y equals anything but 0. Okay? Anything but 0. Okay? So that could be 5, a 7, 21, a negative 800. All of those are possible. So we're going to look at an example of that. So we're going to draw 2 tables. These be 6 lines. This one's also going to have 6 lines. Alright, so we have our X and Y. So we have 0, 0, 1, 4, 2, 8, 3, 12, 4, 16. So I guess I only needed 5 lines. Oh, sorry, I didn't even realize that wasn't on the screen. Give you a second to get caught up on that since... And then this side, X and Y, we're going to go by 2's on the X, so 0, 2, 4, 6, 8. And this side's going to be 3, 11, 19, 27, 35. Alright, so when X is 0, so I'm going to be looking here when X is 0, and I'm going to be looking at the Y value. So if you wanted to, you could get a highlighter there and highlight that X if you wanted to. But when X is 0, Y is 0, so this is a proportional table. If I were to graph it, it's going to go through the origin. Versus my non-proportional, when I look at my X and Y, I have 0, 3. Sorry about that. And that is not proportional. Alright? So we're going to look at a couple of tables together. So we're going to go to the left side of page 24. Sorry, you can see my tables from yesterday, or my lines from yesterday. Alright, so I'll draw a table. It's going to have 3 lines. So we have X, Y, and we have 0, 2, 4, 0, 5, 10. So again, I'm going to look at that X value and what's with my Y. And I'm going to put when X equals 0, Y equals 0, it is proportional, which we also call a direct variation. Easy. All I have to do is look at that 0. But what happens when I have something like this table? Let's see, X and Y. And we have 3, 6, 9, 12, 15, and we have 2, 4, 6, 8, 10. So here if I look, when X is 0, well my problem is, do I have 0 on there? No, I don't. If I look at my X's, I don't. But I can see that these are going by 3's. Plus 3, plus 3. So if I go backwards 1, what's going to come before that? My 0. So if I work backwards, 9 minus 3 is 6, 6 minus 3 is 3, 3 minus 3 is 0. Then I have to work backwards on this side too. 6, 4, 2, 0. So here's my 0, 0. I just had to work for it a little bit. So when X equals 0, y equals 0, so it is proportional, or a direct variation. All right, let's look at another one. Let's look at one going horizontal. We sometimes forget that our tables can also go horizontal. So my goal is to find my x, and I'm looking for where it's going to be a 0. Well, obviously that's not on there, so I'm going to work backwards. 4, 3, 2, 1. Oh, I got to go one more. 0. So I had to take 2 leaps. So this is going by 4s. So before 8 would be 4. Before my 4 would be 0. So again, I have 0, 0. So I'm going to put when x is 0 equals 0, y equals 0. So it is proportional. A direct variation. What about this one? X and y. 3, 6, 9, 12, 15. 3, 5, 7, 9, 11. All right, so let's look. So these are going by 3s. So 9, 6, 3, before that would be a 0. These are going by 2s. So before the 3 would be a 1. So I have 0, 1. So when x equaled 0, y equaled 1. So this is non-proportional. The hardest part for some people is the working backwards. Okay. Let's look at another one. So I want you to try this one on your own, okay? I want you to work backwards and find the x equals 0. Then I want you to tell me what the y is going to be, and then we're going to go over it. So I want you to pause the video, and when you're ready to go over it, I want you to push play. All right, so hopefully you have given this one a try. So let's look. These are going by 1, so before the 2 would be a 1. Before the 1 would be a 0. Okay? These are going by 2, so before the 8 would be a 6. Before the 6 would be a 4. I had to take 2 steps back because I had to take 2 steps on my left. So I have 0, 4. So I'm going to say when x equaled 0, y equaled 4. Oh, sorry, I am coughing a lot right now. All right. This will be non-proportional. I hope you got that one right. So let's do one more where I'm going to have you try it again by yourself. So x and y. And this one I'm going to try to make tricky. And it may not stump you, but maybe it will. Who knows? 3, 5, 7, 9, 11, 13, 6, 8, 10, 12, 14, 16. So this one's a little bit more challenging one. It's about as hard as I can make them. So I want you to try it out, and then I want you to pause the video, try it out, and when you're done, I want you to push play to see if you got it right. All right, you should have had a chance to try it, so hopefully you did. So these are going by 2. So 3 to 5 was 2. So I'm going to go back, and I hit 1. I go back, and I hit -1 if I go back 2 more. I completely went over the 0. Well, let's go ahead and work the other side and see what's going to match up with these. These are going by 2, so before that would be 4. And before that would be 2. So I had 3, 6, 1, 4, -1, 2. I want this the sweet spot right here. So halfway between these is going to be the 0. So I'm going to go halfway between these, which is going to be the 3. 0 and 3. So when my x is 0, y equal 3. So this is non-proportional. On Monday, you will have an assignment where you will have some graphs, and you'll tell me whether they are linear or not. You'll have some graphs that you'll have to tell me whether they are proportional or not. You'll have some equations that you're going to have to tell me if they're proportional or not. And then you'll have some tables that you'll have to tell me proportional or not. So if you have any questions, please email me. Let me know. I want you to be able to understand this. Good luck, guys.